Model selection is the task of selecting a statistical model from a set of candidate models, given data. In the simplest cases, a pre-existing set of data is considered. However, the task can also involve the design of experiments such that the data collected is well suited to the problem of model selection. Given candidate models of similar predictive or explanatory power, the simplest model is most likely to be the best choice. Konishi and Kitagawa state, the majority of the problems in statistical inference can be considered to be problems related to statistical modeling. Relatedly, Sir David Cox has said, how the translation from subject matter problem to statistical model is done is often the most critical part of an analysis. Introduction. In its most basic forms, model selection is one of the fundamental tasks of scientific inquiry. Determining the principle that explains a series of observations is often linked directly to a mathematical model predicting those observations. For example, when Galileo performed his inclined plane experiments, he demonstrated that the motion of the balls fitted the parabola predicted by his model. Of the countless number of possible mechanisms and processes that could have produced the data, how can one even begin to choose the best model? The mathematical approach commonly taken decides among a set of candidate models. This set must be chosen by the researcher. Often simple models such as polynomials are used, at least initially. Burnham and Anderson emphasize throughout their book the importance of choosing models based on sound scientific principles, such as understanding of the phenomenological processes or mechanisms underlying the data. Once the set of candidate models has been chosen, the statistical analysis allows us to select the best of these models. What is meant by best is controversial. A good model selection technique will balance goodness of fit with simplicity. More complex models will be better able to adapt their shape to fit the data, but the additional parameters may not represent anything useful. Goodness of fit is generally determined using a likelihood ratio approach, or an approximation of this, leading to a chi-squared test. The complexity is generally measured by counting the number of parameters in the model. Model selection techniques can be considered as estimators of some physical quantity, such as the probability of the model producing the given data. The bias and variance are both important measures of the quality of this estimator. Efficiency is also often considered. A standard example of model selection is that of curve fitting, where, given a set of points and other background knowledge, we must select a curve that describes the function that generated the points. Methods for choosing the set of candidate models. Exploratory data analysis. Scientific method. Criteria for model selection. Archaic information criterion. Bayes factor. Bayesian information criterion. Deviance information criterion. False discovery rate. Focused information criterion. Mallows's CP. Minimum description length. Minimum message length. Structural risk minimization. Stepwise regression. Cross-validation. The most commonly used criteria are the archaic information criterion and the Bayes factor or the Bayesian information criterion.